Bismillahirrahmanirrahim. Today we will cover the second part of our chapter 6, that is the suspension system. We are talking about suspension system. Today we will talk about the suspension system and the suspension types. In previous part 1 we have covered the basics of the suspension system, how it works and the purpose of the suspension system, and we have talked about the platform or the chassis of the vehicle. Now today's topic mainly focusing on the suspension types, and then we talk about the springs. So there are basically two types of suspension system. One is dependent suspension system and other is independent suspension system. And in dependent suspension system, we call it as solid axles. And in solid axle, we have two types, further sub two types, Hotchkiss and four links. In independent suspension system, we have these 7 subtypes. Those are trailing arm suspension, short long arm front suspension, McPherson stirred, trailing arm rear suspension, semi-trailing arm, swing axle. So these are the 7 subtypes of independent suspension system, and we will try to cover one by one. First, to give you general concept of suspension system, first let's talk about the dependent suspension system. When we are having a dependent suspension system in a vehicle, it is fixed. One wheel is attached to the other wheel with a solid axle. So when we have a bump on one side, it will be felt on the other side also. But if we have an independent suspension system, there will be no solid axle directly combining the one wheel to the other wheel. If one wheel of your vehicle is having a bump, facing a bump, so all the tilt will not be traveled to the other wheel, as in case of a solid axle or dependent suspension system, because of the independent in nature of the both suspension systems. So only that wheel which will be experiencing the bump, that will be affected, other will not be affected. Now, dependent suspension system, both left and right wheels are attached to the same solid axle. So they are attached to the same solid axle. When one tire hits a bump in the road, its upward movement causes a slight upward tilt of the other wheel, as we have seen here. So it will cause a slight upward tilt in this wheel also. Neither wheel is independent of the other. So if one faces something, the effect will be transferred to this other to the other wheel also. Depend a few figures to explain. When one wheel hits a bump or drop into a hole, both left and right wheels are moved. Because both wheels are affected, the ride is often harsh and feels stiff. In solid axle I-beam here, we have this one wheel attached to this solid axle I-beam attached to the other. We have a leaf spring attached here. Now, independent suspension system allows one wheel to move up and down with minimal effect on the other wheel. So there will be a minimal effect, almost a negligible effect on the other side if one wheel experiences the up and down movement. Each wheel is attached to its own suspension system, which is independent of the other. Movement of one wheel does not cause direct movement of the wheel on the other side of the vehicle, as we have seen in the figure. Now, independent suspension, first I will read this thing. A typical independent front suspension used on a rear wheel drive vehicle. Each wheel can hit a bump or hole in the road independently without affecting the opposite wheel. So let's see how it looks like. We have a wheel here, which is mounted on your spindle, and then we have a steering knuckle here. Then we have a upper ball joint and lower ball joint. Okay, same is the here. in which we have a coil spring and a shock absorber, and upper control bushings are here, upper ball joint, lower ball joint, and they are attached with the linkage bar. So they are not directly in contact with each other, so they will experience independently. Now, as we know from our first slide, suspension is the term given to the system of springs, shock absorber, and linkages that connects a vehicle to its wheel. So let's talk about now springs. There are 4 types of springs which are used in the suspension system. First is the coil spring, then leaf spring, air spring, torsion bar, and oblique stabilization bar. This is your coil spring, leaf spring, this is your air spring, and torsion bar or stabilization bar. Let's see. A coil spring. Coil springs are made of special round spring steel wrapped in a helical shape. Coil springs are made of a special round spring steel wrapped in a helical shape. The strength and handling characteristic of a coil springs depends on the following. The strength and handling characteristic of a coil springs depends on the following. So these are the 4 factors on which your strength and handling of coil springs depends. The coil diameter, this is your coil diameter, this one. Number of coils, the turns, number of turns. Basically, the number of turns is the second thing. Height of the spring from top to bottom or from one end to other end, the height of the spring. Then the diameter of a steel coil that forms the spring. So this diameter of a steel coil which forms the spring. So these are the 4 factors on which your strength and handling characteristic of a coil spring depends. The spring rate of a coil spring is determined by the diameter of the spring and the diameter of the steel used in its construction plus the number of coils and the free length, the height. The coil spring, the spring rate K for coil spring is expressed by this formula. K is equal to capital G d raised to power small d raised to power 4 divided by 8 and d capital D raised to power cube, where G is the constant for steel. If we are using the steel as a material, then we have to use that material constant, that is 1,12,050 1 crore 12,50,000 is the constant for steel. Small d is the diameter of the wire. Small d is the diameter of the wire. Okay. N is the number of the coils. D is the diameter of the coil. D, capital D is this one. Small d is this one. Capital D is this one. So the spring rate is also called the deflection rate. Spring rate is also called deflection rate, is a value that reflects how much weight it takes to compress a spring a certain amount. So it is basically the deflection rate, the value that reflects how much your spring can be compressed with a certain amount. Generally, spring rate is specified in pounds per inches. You can take other systems of this, no problem. Coil springs are used in front and or in rear suspension. So the larger the diameter of the steel, the stiffer the spring is. The shorter the height of the spring, the stiffer the spring is. The fewer the coils, the stiffer the spring is. So these are the 3 general conditions. If we have a larger the diameter of the steel, the stiffer the spring is. The shorter the height of the spring, the stiffer the spring is. The fewer the coils, the stiffer the spring is. So we have to find this deflection rate or the spring rate. We have to use this formula for that particular coil spring. Now, second part is of the leaf spring. Let's see. This is your leaf spring. Okay. These are the steel leaves combined together and bolted together on two different part front and the rear, and then they are attached at center. And in between them, there is a spring insulator, some rubber material or plastic material. A typical leaf spring used on the rear of a pickup truck, showing the plastic insulator behavior between the leaves, which allows the springs to move without creating wear or noises. As we have studied, when we join two metal parts, there should be some rubber arrangement, or there's some gasket arrangement to avoid the noise and the vibration while they are functioning. So a typical leaf spring used on the rear of a pickup truck, showing the plastic insulator here when it is bolted or fastened there, insulator between the leaves, which allows the springs to move without creating wear or noise. Now the further detail of the leaf spring, this is your platform or the chassis. Here it is. This is green portion is your leaf spring. The first, the hanger, and the rear one, the main leaf spring, then the steel leaves here, and from the center it is joining with this U-bolt. So from center, this is joining with your U-bolt, center bolt, or the spring perch. A typical leaf spring installation in a rear wheel vehicle, the longest leaf called the main leaf, the upper one, the longest leaf called the main leaf, attaches to the frame through the shackle and a hanger. So this is the shackle and this is your hanger. We will study what is shackle and hanger afterward. The next slide. So this is your main leaf spring, and rest are the steel leaves attached with it depending upon the compression or the spring load we require. Now all multi-leaf springs use a center bolt to not only to hold the leaves together, but also helps retain the leaf spring in the center of the spring perch. This is the center bolt, which is attached along with the rod, having a U-bolts here. This is your shackle and this is your hanger. And here there are also a fastening bolt here, as we have seen here. So see, leaf springs, this is your shackle, this is your hanger. When a leaf spring is compressed, the spring flattens. In normal position, it is like this. When it is compressed, it becomes straighter. Okay, and this is your center bolt. So this shackle provides this travel, this distance. The shackles allows for this lengthening. Rubber bushings are used in the end of a spring and shackles to help isolate road noises from the traveling into the passenger compartments. So rubber bushings are there in the shackles to avoid the noise and vibration to reach on the vehicle passenger compartments. So this is the normal position of this leaf spring. When it is flattened, it is lengthened, and that lengthened distance is catered for by the help of this shackle, which is attached to your frame. Now, typical rear leaf spring suspension of a rear wheel drive vehicle. Here we have this differential assembly, that the differential half axle shafts are going to the wheel hubs. And then we have a leaf spring. Here it is hanger and it is shackled here. We have a shock absorber, and these are the rebound clips which are attached to with each leaf spring, and it is U-bolt here to maintain its center on the axle shaft. Now the third was the torsion bars. First, let's read this. Longitudinal torsion bars are attached to the lower control arm at the front and at the frame at the rear of the bar. So we have this suspension system, the upper ball joint, the lower ball joint, and the suspension, the torsion bars are attached with the lower control arms along with the frame. Let's see what the torsion bar does. A torsion bar resists twistings and is used as a spring on some cars and many four-wheel drive pickup trucks and sports utility vehicles, SUVs. The larger the diameter or the shorter the torsion bar, the stiffer the bar is. A torsion bar twists very little during normal operation, and about 1/16th of a revolution during a major suspension travel. So torsion applied by a control arm here, fixed end of the torsion bar with the frame. I read again. A torsion bar resists twisting and is used as a spring on some cars and many four-wheel drive pickups, trucks, and SUVs. The larger the diameter of the torsion bar or the shorter the torsion bar, the stiffer the bar is. A torsion bar twists very little during normal operation and about 1/16th of a revolution during a major suspension travel events. So this is also one kind of a spring arrangement we have in our suspension system. Torsion bar. One end of the torsion bar attaches to the lower control arm and the other to an anchor arm that is adjustable. So these are the further subparts. This is the lower control arm of a suspension system, and this is the other other end of the torsion bar, which is attached to the frame or other. So this is the height adjusting bolt, anchor arm, and torsion bar arm. The last one is the air spring, which is used in some of the suspension systems. So pneumatic system of the vehicle should be strong enough to provide maximum amount of air pressure, which is required here to have that spring arrangement here. Now, after these springs, we comes to the steering knuckle, as we have seen in other suspension system. The steering knuckle is hard to classify either as a part of the suspension or as a part of the wheel, because the wheel has a steering knuckle on which the wheel is mounted. So the steering knuckle is hard to classify either as a part of a suspension or as a part of a wheel. A knuckle serves two purposes. So let's see what are the two purposes. To join the suspension to the wheel usually includes the spindle where the front wheel bearing are attached. So steering knuckle has a spindle on which the wheel is attached. So to join the suspension to a wheel usually includes the spindle where the front wheel's bearings are attached to provide pivot points between the suspension and the wheel. So it's join the suspension to the wheel and to provide pivot points between the suspension and wheels. Knuckles are used with independent suspension and at the wheels that steers the vehicle. So steering knuckles are used with independent suspension, one, and at the wheels that steers the vehicle. The only knuckles that uses a kingpin is a steering knuckle or an I-beam or a twin I-beam front suspension. So these are the figures we will study. A kingpin, let's see the figures first. This is your upper control arm and this is your lower control arm. This is your steering knuckle and this is the spindle. Okay, the upper ball joint, lower ball joint. This is your steering knuckle. The steering knuckle used on a short, long arm front suspension. So the knuckles are used with independent suspension at a wheel that steers the vehicle. The only knuckle that uses a kingpin is a steering knuckle on an I-beam or twin I-beam front suspension. We have this I-beam. I-beam is attached to the steering knuckle. Then we have this kingpin, which is fastening the I-beam with the steering knuckle. And we have this further arrangement. A kingpin is a steel shaft. This kingpin is a steel shaft or pin that joins the steering knuckle, to the suspension. This is the I-beam suspension and allows the steering knuckles to pivot. So it allows the steering knuckles to pivot like this. A kingpin steering knuckle keeps the wheel rigid in a relation to a I-beam during up and down wheel movement, but rotates around the steering wheel. So here it will rotate. A kingpin is fastened to the I-beam. A kingpin keeps the wheel rigid in a relation to the I-beam during the up and down wheel movement, but rotates around the steering axis to turn the wheels left and right. The steering axis is the vertical center of the kingpin. So the steering axis is the vertical axis of the kingpin. So it is moving right and left, but no movement up and down. Now the ball joint, the last topic, last slide of this chapter. We have an upper control arm, the lower control arm, and upper and lower control arm are joined with the lower upper ball joint and lower ball joint with the steering knuckle. So steering knuckle has to be joined with the upper arm and lower control arm, and that joining is done with the help of upper ball joint and lower ball joint. And here we have a wheel. So this is the upper ball joint shape and this is the lower ball joint. Steering knuckle for front wheel drive. Tapered stud provides a force fit into the steering knuckle or a bearing sports. With this, we comes to the end of our part 2 of chapter 6 suspension system. In next part, we will cover further details regarding the suspension system and its parts. Thank you very much.